Welcome to the world of science and technology. Here in today's video, we are going to explore the secret to affordable antimatter. Yes, you know that producing antimatter is highly expensive. So first let's talk about what is antimatter. You know that antimatter is the matter counterpart, means counterpart of matter. It has, for every particle there is antimatter. Masses are equal for matter and antimatter, okay, but the charges are opposite, such as for proton, anti-proton is there, for neutron, anti-neutron is there, okay. So proton and anti-proton masses are same, but charges are opposite. For proton it is positive, for anti-proton it is negative charge. Neutron, those are chargeless, but those are chargeless. But I am not talking about that thing actually here. In that case, you need to take care of the quarks by which the neutron is made. Okay, 3 quarks are there, and those quarks are not chargeless; they have charge. Anyway, I am talking about right now here antimatter which is affordable. In theory, what is known to us, producing and storing antimatter is highly expensive. Just to produce 1 gram of antimatter, it would cost almost billions of dollars. Yes, billions of dollars. Because extremely high energy is required and advanced facilities are required. High energies are required for the production and advanced facilities are required for its storage, because when antimatter comes in contact with matter, annihilation occurs. So this is the problem with production and storage of antimatter. But hospitals use this antimatter to save lives of millions of patients worldwide. Hospitals use this thing. How this is possible? So that is the topic of discussion in today's video. Okay, hospitals they use antimatter. Which one? Okay, which one? Positron, that is negatively charged electron. Positron is antimatter, which is negatively charged electron, means mass of a positron particle and mass of an electron are same, but charges are just opposite. For electron the charge is negative, for positron the charge is positive. That is known to you. This production of positron is actually affordable for the hospitals, and that's why they are using in their imaging, medical imaging technology known as PET scan. PET, PET, PET means Positron Emission Tomography scans. Okay, actually particle accelerators are used in hospitals, but those are compact particle accelerators. Compact, not like a large hadron collider. That giant particle accelerator. Yes, large hadron collider is a giant particle accelerator. I think that is known to you. But hospitals use particle accelerators which are very compact. And those particle accelerators, those compact particle accelerators are known as cyclotrons. Hospitals use those cyclotrons to produce positron for the purpose of imaging of organs, to detect cancer. Okay, this is used, positrons. So actually what happens, cyclotrons produce very tiny amount of positrons by using the isotope fluorine 18. Fluorine 18, that is the isotope of fluorine. Okay, so amount of production is tiny, is very small amount of production, and it is also controlled. That's why this becomes affordable. amount of production required for imaging, for the purpose of imaging, is very small. And it is also controlled. And there is no requirement for storage of this positron, of this antimatter. Why? Because when fluorine-18 decays, it emits what? When positron decays, it emits something. What is that something? That is gamma ray. When positron decays, when fluorine-18, that isotope decays, it emits positron. And that positron comes in contact with the electron. When the positron comes in contact with the electron, annihilation occurs. And there is a production of gamma ray. And that gamma ray is detected by the PET scanner. Okay. So cyclotrons use the isotope fluorine-18, and when fluorine-18 decays, it emits positron, and that positron comes in contact with electron inside our body, and annihilation occurs. And when annihilation occurs, as a result, there is a production of gamma ray, and that gamma ray is detected by the PET scanners. And that way, a reconstruction of the image becomes possible. So doctors use that image to diagnose diseases. For the purpose of diagnosing diseases, PET scans are used. For detecting cancer, PET scans are used. Okay. So PET scan is what? Positron emission tomography. So this way, hospitals can use PET scans so easily because this is affordable. Because compact particle accelerators are used, which are known as cyclotrons. Okay, so here we can see the impossible becomes possible. But if you talk about fueling spaceships with antimatter, then that is no doubt highly expensive, because in that case the amount of antimatter will be required so high. Huge amount of antimatter will be required for interstellar travel from our solar system to another solar system, means another star. Okay, the nearest one is about 4.5 or 4 light years away, Proxima Centauri. So if you talk about that interstellar travel, that is the nearest one. So huge amount of antimatter will be required, and that would be highly expensive. But to save the lives of the people in hospitals, antimatter is used as a form of positron. That antimatter is used, and that is affordable. Okay. Anyway, so this was all about today's topic, the secret to affordable antimatter. This is the secret. Okay. Means that those cyclotrons are the secret. That fluorine-18, naturally it decays and emits positron. That is the secret. Anyway, so this was all about today's topic. Okay. So this is the end of this video. Thank you. Thank you for watching this video.